much. I'm glad to have this opportunity to talk with you about this wonderful experience I had this past summer. I let you know that I am a member of the Mars Society, which is an international non-governmental group that is devoted to the studies of sustaining human settlement on Mars. And so what we're going to be doing out there is to try to forward this science. This is done basically by performing an analog Mars missions where participants, these are all volunteers, no one's paid, in fact you have to pay to go these things, to live in a Mars habitat and work outside in analog spacesuits. This happens to be the other analog station that is called the Mars Desert Research Station near Hanksville, Utah. I got to spend some time there also. I saw a Mars Society advertisement in February of this year, and it said, hard work, no pay, eternal glory. It's like working at Del Mar. Okay. And it says, work and live with 5 others in a tiny Mars analog habitat called F-Mars that sits on the edge of a meteor crater in the Arctic desert on Devon Island. How could I not want to do something like this? So on April of this year, I was notified that I was chosen for the mission on Devon Island, and then also I would be named commander of the F-Mars 12 2009 mission that would be conducted in July of this year. Okay, I asked myself, where's Devon Island? There you see it on the map. It's basically 600 miles north of the Arctic Circle, and it is basically the largest uninhabited island on planet Earth. And it is about the size of West Virginia, so it's a very large island. Another picture of it, this is actually where we'd be living. You can see the F-Mars habitat. The nearest town was 100 miles away, would be right there, Resolute Bay. Okay, Devon Island is actually the home of an ancient meteor crater called the Halton Crater. It occurred about 23 million years ago. It's about 20 kilometers in diameter. It's about 12 miles, and it is an Arctic desert. It's just like living on Mars itself. Okay, so this is a perfect analog environment for a Mars study. Of course, when I found out, I had to go to Google, and turns out Google has some incredible pictures of it. And there's the F-Mars station. You can see the edge of the meteor crater, and there's what's going to be my home for this coming summer that's passed. Okay, Modern Marvel shot a documentary of our mission, and they shot a sizzle reel, and I wanted to play this. This is about a 5-minute thing that they did, and it kind of introduces us to our crew and everything else that went. Now, we'll go ahead and play this.
I have wanted to go to Mars since I was 8 years old. My colleagues think I'm a little weird.
Would I like to go to that? Absolutely.
Mars is obviously a foreign environment to us. It's remote, isolated, and so a place like Devon Island is an analog for that, meaning that it sort of simulates similar characteristics. It's very much an Arctic desert, if you will. It's very rocky, rough terrain. It's also the site of an impact crater, the Halton Crater.
We're going to be living there, pretending we're on a Mars mission. We'll be doing experiments, we're going to do EVA spacewalks.
One thing about being off the Arctic Circle, it's cold. Well, on Mars, it's going to be cold, so we have about the same temperature then. We're actually doing everything in spacesuit, in simulation. Now, we can go and do it without spacesuits and all that, but well, when you're doing the spacesuits, trying to even write or anything else with your gloves, that's a major problem here. You need communication with each other. You're in a fishbowl, what we call it on.
It's warm, very warm. Maybe it wouldn't be warm in March.
We're going to be carrying heavy packs with us, and so one of the things we're doing for training is walking around with packs to get used to the weight. And most people are probably just carrying, dead weight packs, but I'm carrying my son, so I get to have a nice hypertension at the same time.
When you go to Mars, you guys are being limited on what you bring with you, on the equipment, on the supplies, on the tools, and you can't just run out to Home Depot
various places because they didn't watch other people's back. They weren't working safely. And we're going to have a little safety meeting before every EVA. And say, all right, what could go wrong? What would you do? How will we respond to this?
Well, we are all joking about polar bears. Hopefully we won't have any polar bear encounters, but there are polar bears, so there are safety concerns that we have.
Oh, look, there's polar bear footprints. We have to worry about on Devon Island that we don't have to worry about on Mars. At least we hope we don't have to worry about on Mars. That there are polar bears there, so we have to be always aware of it. I know polar bears are really cute, but they're one of the few animals that will actively search and eat a human being.
All of us crew members are doing some preliminary training with shotguns to try to make sure we know how to handle the guns, and how to load it, and shoot in case we need to.
This is a 12-gauge pump-action shotgun.
All right, let's throw a polar bear. Hit him right in the teeth. In general, I'm going to be kind of a interdisciplinary scientist on the crew because I have a lot of different science backgrounds. So I'm doing a lot of experiments, be helping out with a lot of tasks regarding science. Then when I come back to my day job, I think I'll have a better understanding of what the crew goes through on a day-to-day basis.
I am a chief medical officer, so I do have the medical role. Also, I'm going to be responsible for sort of keeping a daily journal of everything that goes on. How do you prepare for the trip? How does the generator work? How do you get water? Those type things. So I'm going to be responsible for basically writing the book of what happens during our month-long mission. I probably will be doing some psychological studies, and currently I'm in charge of food.
I'm an executive officer on the mission, which means that I'm going to be working very closely with Vernon and Sander. We're going to be making use of a UAV, or an unmanned aerial vehicle, which is a small, in essence, remotely programmed airplane that will go out and capture imagery and other sensor data and send that back to us on the ground. Awesome. So if I can send this unmanned aerial vehicle out there, have it survey a large area, and identify just those particular locations of interest, then that's where I can send the field challenges. There it is up there.
We use ATVs to simulate unpressurized rovers, similar to what you saw with the Apollo astronauts. They had a lunar rover to get to further distances than they could just by walking.
Is your gas right here? You just push your button, move the bike, right? Automatic right to change gears at any time.
I'm going to be bringing a seismometer and installing the first seismic station on Devon Island. And it's important scientifically to understand the interior of the planet, what you can't see at the surface, as well as characterize any seismic hazard that may be.
I'm a little nervous just because this is something that is brand new experience to me. Adapting to the conditions and to the isolated environment is going to be a challenge. It'll be difficult, but I don't think it's something that, well, that I can't do.
My cat's focused.
A person who steps out on the porch knows more about the world than the person who stays indoors. And to me going into this Mars simulation is I'm stepping out on the porch. And this is why I think we'll be doing travel. And I'm really excited by stepping out on the porch and being one of the people who gets to do that.
This is going to be a lot of fun. This is going to be a great adventure. I'm really looking forward to it. We certainly have the technology to go to Mars with a small group of people and do exploration. We shouldn't just go out and explore Mars with a small number of people, but we should actually sell the planet. That's kind of our destiny as a species, is to go out there and establish this
Okay, that was the video that they shot, and unfortunately, just before the mission, Modern Marvels went bankrupt. And so therefore they didn't get to shoot the documentary. So, but we went ahead anyway. 2 weeks before the mission, our crew would meet for the first time in Denver, although we were in telephone communication. Stop for a minute to introduce you to the various members of my crew. This would be Christy Garvin. She's a Bachelor of Science in Elementary Education. She teaches a gifted and talented 3rd through 5th grade. She's an EMT, a private pilot. She was voted Georgia Teacher of the Year, and she made it to the final 32 list of being an astronaut. In fact, we didn't know whether she was going to make the program or not, and she got cut a week before the program started, so she was able to join us, which is kind of sad because, in a way, she wanted to be an astronaut. Next person is Joe Pelea Jr. He has a Bachelor of Science in Electrical Engineering. A Bachelor of Science in Electrical Engineering, has a Master of Science in Nuclear Science and Engineering from MIT, and he is a Vice President of the Four Frontiers Corporation. Next we have Christine Ferrone. She's the one that shot the polar bear. She has a BS in Physics and Astrophysics from Carnegie Mellon, MBA from the University of Florida, and she works as NASA with the International Space Station for the payloads. Next we have Stacy Kusek. She has a BA in Aerospace Engineering, Master of Science in Planetary Geology, in which she studied Mars, and she is also a lead trainer for the astronauts that go to the International Space Station. And then we have Brian Shiro, has a BA in Geology and Physics, MA in Earth and Planetary Science, works for NASA, does the tsunami modeling in Hawaii, and he actually worked on one of the proposed Mars landers. There's myself, and this is Robert Zubrin. He's the president and founder of the Mars Society. And then Brian Inke, he's to be the captain of the Denver Mars Support Team. Now, we did have a mission support team that we would report to every day about 7 p.m., and we had one that was located in Austin. We had one located in Australia. And whenever we had any questions, they could not respond to us for 40 minutes because it takes 20 minutes for the signal to get to the Mars and 20 minutes for the signal to get back. So we're trying to do a real Mars simulation. In Denver, we discussed our planned missions. We placed orders for our food supplies and designed our mission patch, which I have an example over there. We also set up this incredible website. If you haven't had a chance to go to it, it's www.fmars2009.org, which a lot of the things I'll show you today you can actually see there. In February 2009, we did have a large group of people that helped sponsor us. Then, of course, the major contributor was the Mars Society. Spent over $50,000. Most of this is for airplane to go from Resolute Bay to Devon Island. And this goes to show you some of the other sponsors that we had. Had quite a few people. And then, of course, I have to admit that my favorite one was Del Mar College. They were a sponsor for me. They provided me a little bit of cash for the airplane. The Natural Science Department supplied me with a water condensation device. The IT group supplied me with a very good laptop computer and some very expensive technical software. And then the GIS department allowed John Nelson to teach me how to use GPS. And this is something I didn't know about. And we had some real long nights on this. In fact, all the maps that you see there was prepared by him. For your information, I want to point out to you that this was not free. This was very expensive to every one of us. Well, I had to buy my own airplane ticket to go from here to Resolute Bay and back. Had to buy my own bedroll, my own clothing, my own boots, my own clothing, and everything else. But was it worth it? You bet it was. Okay, on June the 28th, I flew to Ottawa, Canada, and there at that night, I met the 3 other crew members. The next morning, it's going to take us 12 hours to get from Ottawa to Resolute Bay, our final destination. And we will stop at Iqaluit, Nanisivik, and finally to Resolute Bay. So let's take a look at what it was like when we arrived in Iqaluit. Here it is. This is supposed to not be there. This is supposed to be warm. And it turns out that the winter has not yet left Canada. So I said, uh-oh, we're kind of in trouble on this. This is the 1st of June almost. Okay, here was Iqaluit. Now, we left this great big town of Ottawa, and now every town we go to, the population is going to get considerably smaller. This is Iqaluit, the territory of Nunavut of Canada, a population of around 2,000, has a very unique airport that you can see from basically from space. While we were there, we had to stay there for a couple hours. The airport was right next to the harbor, so we went out there and seen some of our first icebergs. Again, the ice hadn't melted out of the bays yet. From there, then we got on a prop plane and went to Nanisivik, which is a big city of 20. Basically, it used to be a mining town that was abandoned, and now it is used to fuel airplanes that go up into northern Canada. Okay, here we are at the Nanisivik Airport. You can see we do not have a paved driveway, a paved runway. In fact, it was muddy. I told everybody, well, look, I'll pay for lunch if we go there. And somebody stepped out the door here and they say that, not in here, you're not. I mean, they didn't even have water, they had nothing. So I knew now, we're really getting into someplace. Okay, from there we continued with our plane and we landed in Resolute. I call it Resolute, it's actually called Resolute Bay. And it is the largest town for literally hundreds of miles around. And what we see, there's Resolute Bay. It has a population of 250, at least 1,000 husky dogs that you could hear day and night, and one frozen bay. Although it was supposed to be thawed out, it was not yet. Okay, here's Resolute. It's basically filled with Inuit residents. This is what it looked like throughout most of the town. And here are some of the local residents. Their travel was around basically with ATVs. Most of the years it's in snowmobiles. Okay, and you can see that the Inuit love to hunt polar bears. So, you know, if you keep preserving polar bears, they like that. Okay, this is where we stayed in for a couple of days. It was called the South Camp Inn, and you can tell from this was obviously a 5-star hotel. All right, from there, now this is the first time I'd ever seen midnight with the sun on. So, you know, the land of the midnight sun. So we're on standard time, Central Time, and this is midnight. And this is the dark it'll ever get for the next month. We will never see a sunset as long as we're up there. Okay, now if we're going to travel around in the Northwest, you're going to use what's called the Twin de Havilland Otter planes. These are planes of choice. These things can land with a ton and a half of material, basically on the size of a football field. Here we see we're loading. We're going to carry 5 ATVs with us. This is 2 of them are being loaded into the Otter. These things weigh about 550 pounds each. Now what was really good here, we had a machine to load them. When we come back, we have to hand load these things. So we had to be in pretty good shape for that. Okay, so here is the Otter. It's loaded, ready for Brian and me to leave. You can see one ATV. There's the other TV. Our luggage is a barrel of fuel in there. There's our food supply, everything else. And so I asked, well, can I get some coffee? And then you ought to see the look that they gave me. I said, no, you're not. By the way, you can see it was cold. And this is, in the first week of July. All right, I just wanted to show you a little movie. Now, this is going to be a little loud because of the way the sound system is. This is going to be the first time I realized this is for real. So here we are at the Resolute Bay Airport, and we're taking off. And when the plane was going up, I said, oh my gosh, this is for real. That was the first time that it hit me that we were going on this adventure. Okay, we would fly about we flew about 10 minutes over the island that Resolute Bay was on, and then we'd fly about 30 minutes over the ocean. As you can see, there was supposed to be no ice there. So the winter was still there. There was a lot of ice on the oceans. After that, then we hit Resolute. We hit Devon Island, and we would fly about 30 minutes on Devon Island. So you see, we're really in the middle of nowhere when we land there. And this is going to be a little bit loud. I want to show you, this is what we first saw as we were coming in and landing on the dirt strip. So we can see the habitat. There's the habitat, sitting on the edge of the meteor crater. That's going to be our home, in the middle of nowhere. Okay. Let's see, I have to apologize because this program had a bit of a problem with this computer. Okay, you can see the strip that we landed on. This is these airplanes can land on anything. You know, if you want to buy an airplane, this is the one to buy, a de Havilland Otter. Okay, so basically we leave, we take off our load of equipment, and now the plane, it's about an hour and 20 minutes for it to get there. It's going to go back and pick up the next crew. So meanwhile, Brian and I, we're going to put some stuff on our ATVs, and we're going to go to the habitat, which we can see across over there. And as we get down to the bottom of the hill, where is our road? We have no idea. There's not supposed to be any snow there. So what let's do, let's go walk for it. And that's when I discovered that my boots were not waterproof. And so we walk around, we finally discovered that there was the road located there. Okay, so we had these two-wheel drive vehicles, and they told us that they could not go up snow. All right, but we're going to try it anyway, right? Well, as you can imagine, it's not going to work very well. All attempts to get up the road failed with the two-wheel drive vehicles. You see, well, all you got to do is dig the snow out. Well, the snow was about an inch thick, and the rest of it was like about a foot of ice. So that wasn't going to work. And then what happens, which is typical with our adventure in here, Brian's ATV died right there, and mine is stuck in the snow. So this is really starting out well. Okay, then finally the other crew arrived, and Joe was the more adventuresome kind. I said, Joe, you've got to find us another way. So what he did is he took the vehicle, went about a half a mile down. He found a trail that none of us had enough nerve to do, but he did, and he got all the ATVs up for us. All right, and then what we did, we hand carried about 2 tons of supplies to the ATVs and to the trailer so we could take them up to the hab. By the way, this is midnight there. Okay, so here's our trail to the hab after several trips with the trailer, and let me go back to this one a minute. That's about a half a mile up there. Okay, so this is our home on Mars. We call it the hab. It is short for the habitat. And you can see where we get the name FMars, because the fmars.com at flashline.com contribute the most of the money to build this. So FMars stands for the Flashline Mars Arctic Research Station. All right, of course, the next day we were there. Brian was he was a kind of a climber, so he climbed up to the top of the hab, and we have the Mars Society flag. And as soon as we got down, then the winds started hitting. And this is going to be a fun thing to do with these winds. Sometimes they're going to get up pretty strong. Okay, this is the 4th of July. You can tell by the way we're dressed. All right, this is before we go into simulation. And you notice that Joe has his shotgun, just in case a polar bear happens to come by. Okay, what we'll do is we'll walk around our habitat to become familiar with it, and you can see right there, we're literally on the edge of the meteor crater. Now, we actually set up a satellite dish ourselves, and I wanted to point out that this is pointing at 5.5 degrees from the horizon. Luckily, we were able to get over that hill. Basically, all of the communication satellites are sitting over North America, and luckily, we were able to find one satellite to get our signals out. Okay, we didn't have a nuclear generator, so we had to use diesel generators, and it was located away from the hab to get so we could have electricity and get rid of the noise and the diesel fuels. So here we always had to have the doors closed because we had no telling when we were going to get a snowstorm. And this is basically our 2 generators, the main one and a spare one. They would work for 8 hours, and we would have to go and refuel them every 8 hours. Now, we did this without spacesuits because we only had 1 spacesuit each, and we didn't want to get them dirty. So there would be times in which we were out of simulation. And there's our 2 months fuel supply, literally sitting on the edge of the meteor crater, so that would last us in case we got stuck there, and enough for the ATVs. Okay, what is life like inside the hab or the habitat? Let me take you in there and show you how much space we have for everything. Okay, this would be the main airlock that gets into the habitat, and whenever we went on a mission, either entering or leaving, we would stay there for 5 minutes. And we'd have a Capcom that would tell us, okay, we're entering into the habitat, we're getting ready to enter the habitat, we have to be recompressed for 5 minutes, or we're getting ready to leave, we have to be decompressed for 5 minutes. And we did this because we're trying to simulate that we're actually on Mars. All right, then you come right out of the airlock, there's a spacesuit room. To come around the corner, this is our science and engineering room. And then this is to the engineering airlock. Now again, when we went to do the fueling, we did not wear the spacesuits. All right, and then in the middle of it would be the hallway to the shower room and to the toilet room. And you can see that our improvisation, this is what you do when you engineer, when the handles break on the showers. By the way, we did get to take a shower once a week. And I don't know if you know what a Navy shower is. It's where you get this cold water on you, and then you put the soap, and you try to wipe off as much soap as you can, and then you turn on the water and rinse off, and that's it. And we got to do that once a week. Now, you could take sponge baths, which most of us tried to do anyway. This was the interesting one here for all of us. You had to separate your solid and liquid human waste. And you can see the girls used the bucket, the boys used the other thing. They were all poured into that one area. And then whenever you were done with your business, you had to go and tie that up because we had to incinerate that. Remember, we wanted no liquids in that. So we affectionately call that the poop barrel that we would use for later incineration. Okay, this is a ladder going upstairs to the living area. Again, looking down on it, you notice there's a piece of sponge that's across that. That's because for the first time they had somebody that was tall there, and I hit my head so many times I had to do something else about this. Okay, this is looking upstairs in the living room, the kitchen, and the dining room. This is basically unoccupied, and this is when we're busy working and cooking. Another picture of it, basically unoccupied, and then this is what it normally looked like. Now, because we had this girl that was from Pittsburgh, she insisted we have Heinz ketchup, so you'll always see that sitting in there. Okay, this is the kitchen area. We did use propane, and we did have a microwave. Trouble with propane, we had to use it very sparingly because when it burns, it gives a lot of water vapor, and then the water vapor would get into the hab, and it would create mold starting growing, so we had to have dehumidifiers to take this out, otherwise we'd have mold growing all over the place there. All right, Christine, bless her soul. Now, we all took turns cooking. I cooked at least 3 meals, but she loved to cook, and she was an Italian, so we always ate a lot of Italian food because she was willing to do it. And you know what? We were willing to let her. So, bless her soul. And here, here she is telling people that going to International Space Station, and here she is working there. Okay, we always ate breakfast together, and we always ate supper together because of the lunchtime we were basically on missions. So this is make sure that the group worked together as a group, and you can see this is what normally our suppers. And as you can tell, we have Italian spaghetti and all this here, so that meant Christine had to cook that time. So this is going to be our living space and our working space for an entire month. Now, Brian happened to have his birthday, and then Christine baked him a pineapple upside down cake, so we celebrated his birthday. Okay, upstairs, we go a little bit higher. It's in the loft. This would be our water supply and our food supply. We did have a hot water heater that contained about, I think, 5.5 gallons of hot water, so you had to use it very quickly. This would be our 30-gallon water supply that we would have. This is showing some of our food supply. Basically, we had enough to last for 2 months. Some more pictures of it. We'll point out to you that we have no fresh fruit, no fresh vegetable, no bread, no meat, anything else. Everything had to be canned. After all, we are on the simulated space station on our way to Mars. So we tried to, simulate it in every way possible that we could. Okay, this would be the doors you can see on the right there. It's leading to our spacious bedrooms. All right, this was my bedroom. And I got to see that top up there. I got to know that very well every time I got up in the morning because I'm used to sitting up. Well, this is about, of course, if I could not sit straight up and down there. And you can see they had lots of places for your closet to put your clothes. Okay, this is the empty crew quarters, and so it shows you that this is what all of us, we each had our own bedroom, okay? So this is what they look like. Okay, this in midnight, of course, what you're looking at is midnight. And some people had problems sleeping with all the daylight, so what we did, we had the little plywood circles that we'd go and put on the windows to try to, and it got fairly dark in there by doing this. What about obtaining some water for drinking? Well, what we did is we used the melted snow for our water supply. You notice that the habitat's a half a mile up there, and by now you can see that the snow is really melted. So this is kind of helping us a lot. One of the things is we were worried, if this keeps melting, we're not going to have any drinking water. And we were kind of concerned what we're going to do about that. But it did last long enough for us in here. So there's the habitat. This is Christy, I'm sorry, that's collecting water. This is what we did about twice about every other day. Here we see there's about 5, 10, 15, 25, 30 gallons of water that we would carry up into the hab. And once we get it to the hab, we put a couple of ounces of bleach in it to kill whatever germs they were. And then we'd have a battery-operated pump that you see she's putting the battery to that would pump it upstairs and to our loft after sitting for about 12 hours. Our average water consumption was incredible. We used only 2.9 gallons per day per person for the entire month. The International Space Station uses about 5 gallons a day. So we were able to use considerably less than what they do on the International Space Station. Okay, of course, now we did have the water from the weekly baths, because there's 6 of us, so every day someone was taking a bath. And then we washed the dishes, and according to the Canadian law, we had to have a sump to dump this in. So here Christy and Stacy are carrying it to the sump, and they would dump it into this. Now we had to use biodegradable soaps and all of this. So this was according to Canadian to Canadian law there, or actually the Nunavut territorial laws. Okay, then here was the other wastewater that we collected. Now, as you can see from the barrel, that is heavy. You know, it's a lot heavier than diesel fuel. So we would fill up one of those about every 3 weeks. So we filled up one and a partial one. And all of this had to, of course, be flown out. This is the incinerator that we had. We had a $5,000 incinerator that you see over there. We had a little bit of oil injection to it. And I want to point out something to you. If you look right there, how much smoke do you see? We're burning human waste right there. So this was an incredible machine. Now, we didn't burn anything that had plastics, and so anything that had plastic or glass or cans, we took out. So we're trying to make sure that we're good stewards of the environment there. So this was, I thought, was an incredible investment. Okay, one of the things that I always had to worry about Christy, she was light. And we get these 70-mile-an-hour winds, and this one day we were going to do the generator, and I was afraid. You can see there's the edge of the meteor crater there, that she was going to be blown off onto the meteor crater there. So we had some really powerful winds there at time. Now here it is, just going back to fuel the generator. Although you can see that the snow is melting, the wind chill factor is, I think, is 80 degrees below zero, or at least that's what it felt like at that time. So whenever I went outside, I think there was only 3 days that I did not wear thermal underwear and didn't wear the ski helmet and gloves and everything else on here. Okay, whenever we had our extravehicular activities after the July the 1st or whatever it was, the 4th of July I think it is, when we went outside, we would put on spacesuits. And what we did, we helped each other with this. These were generally 20 to 30-minute procedures. And we see here where Joe is helping Stacy put on, get her helmet buckled on. And you can see where Christy is complaining, I don't have any air, please get these air vents on. So that's what I'm getting. Once you have these helmets on, we have these air ducts coming in. And if you don't have that, you're going to be yelling pretty loud. Okay, and then here's Joe helping me getting ready for an EVA. Okay, when we're suited up, again, we spent about 5 minutes in this airlock, and we basically, remember, we're trying to simulate being on Mars. That was really cool. We'd shut the door and say, okay, Capcom, we've now entered the decompression chamber. Says, Roger, I'll let you know when your 5 minutes are up. And she says, okay, your 5 minutes up, you can now exit. And here we are exiting for a mission. Okay, here is a typical spacesuit to show you how we're ready for a mission. Our spacesuit weighs between 40 to 45 pounds, simulating what it would be like if it actually weighed on Mars, because Mars has about 38% of gravity on Earth. The water from the backpack, you can see I have a little thing inside the helmet where I could get water. I don't think I ever drank from it. We had a backpack fan that would last for about 5 hours. That would simulate you having an oxygen tank on for about 5 hours. So we're trying to do everything we can to simulate what it's like being on Mars. And this was the hardest thing that I had, was the two-way radios, trying to find that stupid button, trying to talk with, because you really can't hear each other very well inside these helmets. And then we had the thick gloves. That was something else that we had to learn to do all over again. It's real easy to do things when you don't have gloves on. Try to do it with gloves. And the worst part of it is there's no snacks. We tried to come up with different ways to put snacks inside our helmet, but it never worked. Okay, because of the possibility of polar bears, we always had a gunner. And he was always out of simulation, and he's armed with a shotgun. Now the shotgun had hollow point 12 gauge slugs. Theoretically, that's supposed to stop the bear. Luckily, this is the only white furry animal that we ever saw. And we didn't test the gun out on him, okay? So he's still there. This is Christine and Stacy on our first EVA. We're putting on the spacesuits, going out to see what it's like, getting used to wearing them. And then this would be myself and Joe and Brian walking around for the first time, making sure that everything works. Next thing I want to introduce you to is the ATVs, what we have, of course, is the all-terrain vehicles. Okay, we conducted missions on Devon Islands by using ATVs, which turned out to be a constant source of problems. We had lots of problems with this. In fact, the one that I used had no brakes. And going up and down some of these 50 and 60 degree slopes and trying to keep it in first gear was kind of a real thrill. In fact, we had no equipment, so Joe, because he was an electrical engineer, he kind of figured this out. We actually had to take the carburetors apart and boil them in water to get them working, and we always had to change the spark plugs all the time. We had so many problems with one ATV that Joe came up to the final solution. This is the only thing we can do to this ATV. But later on, we digressed, and we were able to get it to work. So once we're in simulation now, you can't take your spacesuit off. So basically, we were getting ready to start, and Joe's ATV died because a spark plug was fouled up, so because he had to choke on too long. And so here he is taking, again, with the gloves and everything else, changing spark plugs on the ATV. Sometimes we got lucky, and they all worked. Now, this is the kind of terrain that we would drive over. And if you were to tell me that we could drive an ATV over this, I wouldn't have believed you. And because I had a GPS unit with me, I always did this with one hand. And so that was a real experience for me. What about navigation and mapping on Devon Island? Well, we did have various GPS units, remember, that were donated by, or loaned by Del Mar. Now you say, well, Mars doesn't have GPS satellites on it, but maybe it will by the time we get there, and at least we can put some repeater stations around where we could use these. Okay, this is typically what it was like on a mission. I'm not sure how loud this is going to be, but we're going to stop and take a look and see where we are. And see, we can't hear each other talk in here. I'm trying to find the stupid button, and about half the time I was able to do that. The other half the time, it took a long time for us to carry on the conversations with each other. Again, I apologize for. Now, this was an unfair picture because she didn't tell us that she was taking this. I said we need to go this way. Joe said, no, we need to go that way. So that was you can see we were always unanimous on which way to go. Well, we decided we'd try Joe. He really wanted to go that way because he wanted to go see something, so we took his way and we got lost. But eventually, because we had the GPS units, we were able to find our way back. Okay, one of the cool things that we were able to do, Brian was a computer wizard, and he had a wristwatch GPS unit. And we would one person would always wear this on a mission, and this is one that I wore where I did a walking mission around the Haynes Ridge from the FMAR station. Walked about 1.5 miles, showed the elevation changes, and you can see every once in a while when I almost fell down, my heart rate would go up, so you could see, unfortunately, all that was recorded. This was another one in which I was basically out of simulation, but Brian wore the units, and this one here was about 5 miles. And this is put on top of the Google Maps, which I thought was really cool. And basically, this is where we're driving, and this is where he's walking back and forth. And where you see some of the spikes in heart rates, that's because we had some soft stuff that we would drive over, and sometimes he was, oh my gosh, we're going to get stuck, but we got through those. And then this is our really big one. This one was 22 miles. You can see that from the loop, there's one that goes way up there and comes right back. That's where we got lost with Joe. And on the way back, we decided, well, look, Joe said he just started going and said, wait a minute, Joe, that's supposed to be the road there. No, no, this is the way we're going. So we come around again. You know, Joe, we've already been here. No, no, let's keep going. Well, the rest of us stopped. No, we're going to wait here. And you can see where we had made that great big loop. So finally we got back, and that was, our fans were almost out of battery juice, and you know, we had to get to the habitat because that was our only source of air. Okay, now to the science missions. Christine brought in what was called a Class 4 low-level laser light therapy device, and it's only the second kind of was ever built. And there's the device, and then she has this laser gun that she's putting on our shoulders and on our knees. And what that does, it provides really deep heating. And as a result of that, we think that we suffered no muscle injuries at all. So we were the first crew to actually go there and suffer no injuries. We would do the treatment before and after, we do the stretching exercise, and we were all very impressed with it. All right, then we had another really cool thing. This was the Omega rover. This rover was built by the students of the University of Florida, and it was actually operated by that via the internet. So we had a computer setting outside, and they actually ran that from Miami. From where, I'm not sure, Gainesville, or wherever the University of Florida is.
Gainesville, yes.
Is it?
Go Gators.
Oh, go Gators, okay. So what I found was remarkable is that the instrument worked well in the rocks, so we were convinced that it would get stuck. Well, they would run it for about an hour every day, and about after 2.5 weeks when the motherboards fried, and that was it. So we were really thrilled that they were able to use it at least for that long. This is the aerial, the airplane that we talked about earlier in the sizzle reel. Now when you're trying to do this in a spacesuit, this is a little bit more difficult in here. So here's Christine and Joe preparing for the unmanned aerial vehicle. And Joe's getting ready to launch it. And basically it was controlled with a laptop computer. The unfortunate thing, it was so cold that the laptop battery wouldn't last very long, so we found a way, because he's an electrical engineer, we found a way to keep the ATV running and connect it up to the battery of the ATV, and that way we were able to go and control the airplane. So here it is. It has a camera on it, and this is one of the first slides to show you that we would have to go and adjust the cameras, but this is what this thing could take a picture of. So there's the habitat, just flying about 800 feet up. And it's about 35-mile-an-hour winds. So it would turn out that we would actually go through and start flying it lower and adjusting the resolution of the camera, and we were able to get some fairly good films on this. I want to point out to you, ideally, the UAV would be able to spot mineral-bearing hydrothermal pipes that were located on this geological map. I have an example of it here. Let me show you what a hydrothermal pipe is. There's one right there, this big orange background. Of course, when there's one this big, we can almost see it from a space satellite, but there's going to be a lot of them that's going to be very tiny, and that's what we were hoping to find with the UAV. So you would think that it would be easy to go in and climb and take samples of this. It turns out that when you have that spacesuit on, that big backpack on there, it's not all that easy. So again, even taking samples, when I'm trying to hit it with a hammer in there, I would miss it half the time because the stupid helmet would be in the way. So you had to learn to turn your head just right, get the backpack just right, and all of this. So these are really cool things that you need to practice on if you're planning on going to Mars. But I tell you what, the view was spectacular from these, when you were up on these hills. We tried to send the UAV over where I was working, and I thought he was aiming at me, and he didn't. The wind pushed it over and hit the hill right beside me. It knocked the propeller off, and luckily, I was able to find the propeller and the nut to the propeller, and we were able to use it again. Okay, this was another one that Brian had. It was a portable all-in-one seismic station testing for astronauts. This was basically conducted by Brian and Christy. This was something they were able to practice without spacesuits. It was really easy. Then when they went to put on the spacesuits and the gloves, trying to tie the cables and the wires and all that turned out to take, it was supposed to be a 5-minute thing, took about an hour. The ideal of the antenna was that we're about 2.5 miles away from the station. We're going to try to record the seismic waves at the habitat. It would turn out that something went wrong. We were never able to do this. But anyway, here they're setting up and stretching the wires for the seismic unit. And of course we had to dig a hole, and with all the breccia there, trying to find a place to dig a hole was a lot more work than what we thought it was going to be. Finally, there it is. Now this is the kind of unit that you would hope to take to Mars. So this is one of the latest type technology. We had some really incredible stuff with us in here. This is a top-of-the-line seismic unit. So basically, I'm checking all the equipment, make sure it's functioning, and you can imagine trying to go through and put all these cables together and try to push all those buttons, and he realized he couldn't push the buttons with his glove, so he had to pick up a rock to go through and program with these buttons on this. And then we had a solar panel to put on top of this to keep the battery going. Let's see. This is a movie just to show you what it was like leaving the habitat, and you're going to hear the click of a radio, and that's saying, okay, you can get ready to leave. So for the next mission, I'm going to show you how we would leave the habitat. That was leaving. So now you can tell, of course, the wind is really blowing. It's Christine getting out. Stacy getting out. Brian getting out. And then finally Joe getting out. And then we would close the door so that the HAP could get basically recompressed. Okay, now this mission was called a time domain electromagnetic ground survey. Basically what we're doing, we're going to look down 2,000 to 3,000 feet to see how much groundwater there is in this. Another mission was to find and produce water from minerals. This would be the first time it was ever done in a Mars analog environment. And gypsum was reported at Gemini Hills, and we went to find it. There somewhere would be water-bearing gypsum, and there it is. And this is what we're going to get our water from. How can I tell it's gypsum? Well, I can scratch it with my fingernail, except I don't have a fingernail because I have gloves, so I use the rock hammer. Okay, now we're busy collecting the samples, and what I'd like you to watch now is how we're going to be collecting this sample, and a little movie on how we're going to actually make water from this gypsum that you see collected right there.
Okay, we're now at the Mars laboratory, in which we went out on the EVA, and guess what we discovered on the EVA? We discovered a mineral called gypsum, which is the same kind of mineral that we actually find on Mars. And here is an example of what gypsum looks like. What is really important about this gypsum is it contains water. Where you say, well, look at this gypsum, it looks like it's really dirty here. Well, it really doesn't make any difference if you have dirty gypsum or if you have clean gypsum like this. Water is water. Now, the only reason we may want to get a clean gypsum is because we may want a clean byproduct of it's called plaster of Paris, which we will get after we extract water. All right, how much water can we actually extract from gypsum? Well, this particular piece right here contains about 2 teaspoons of water. All we have to do is heat it pretty close to around 300 degrees Fahrenheit, and we'll be able to extract the water. Now, as an experiment here on Mars, what I decided to do to save time, instead of having go and putting a big piece of rock and heating it, I decided to get some dust. Well, you see, this is fairly easy. In fact, actually, we can scratch gypsum with your fingernail. So what we did is we ground it up and we made some dust, and then we put it in a mortar and pestle and we ground it up. And now we have basically 100 grams of gypsum right in here. Now I have here a condensation device. I have a heater in which I will put the gypsum in here, and then I will move this over and put the condensation device on this. And over time, what we're going to see, which we'll come back to, we'll start seeing the close-up where the gypsum, the heat will break the water out of the gypsum, and the water will come along this hollow tube in here, and we'll see the water along here. Okay, now we're basically 15 minutes later, and you'll notice that in 15 minutes we already have water that's actually being driven off of the gypsum by the heat. The water vapor then comes up into the tube. You can see where it will look at a close-up of this in a minute, but you'll see where the water is condensing in here. Steam will bring more water here. This is a tube inside of a tube, and so what we're seeing in here is that we have cool air here, hot air here, which is making the water condense in here. And in a few minutes we'll take a look and we'll actually see where there is liquid water at the bottom of the tube. Notice the water that's actually being driven out of the gypsum. It's condensing here, which is being created with steam. It's coming further out in here. We see where it's being condensed along the tube. And in fact, there's a drop of water that's getting ready to fall down about water. They got a little bit of a tap. We have a bit of water that's getting ready to drop. There we go. So we actually have water that actually comes out of the rock. And we'll take a look at this a little bit later, and we'll have a little bit more water that's coming out of the rock. It's actually 2 hours later, and what do we have? We have nothing. The gypsum has been, all the water has been taken off the gypsum, and all we have now is plaster Paris, which we can use for cement or for molding or for making sheetrock or whatever you want to make. But the most important product that we have here is water. And what do we see here? This is water. I'll take this off for you.
Now we're using literally.
See that showing up here? Okay, what we have here is liquid water. Now you've got to recognize that this was probably water about 30 million years ago. On Mars, we find the water is going to probably be a few billion years ago that the water formed in the gypsum. And so here we have what we can drink, what we can use for making oxygen, what we can use for making energy, and for the plaster Paris, here I created I took an earlier sample of the plaster Paris and made a little mold and made a little emblem out of it. And so this is one of the useful minerals that we can find on Mars, and we were able to create this in the Mars habitat with the Mars 12 2009 crew.
Okay, so this was the gypsum. In fact, I have it sitting over there, the actual gypsum that we used, and I actually have a vial of the water that we actually captured. So this is the first time it's ever been done in a Mars habitat, in a Mars-like environment. So we were really proud of doing that. Here's some memorable pictures we took. By various crew members on various EVA missions. This is known as an Inuksuk. These are built by the local Inuits that would come by in the wintertime on ATVs, on snowmobiles, and they use this to say, okay, there's a food supply somewhere nearby. We wondered if we'd be able to climb high rocks and mountains with these spacesuits. It turned out that it was fairly easy. This was a rock that was about 2.5 miles away from the crater that was blown there by the impacting. Here you can see how desolate the area is, so basically a very Mars-like environment. Here's one of the hydrothermal pipes that we would see located near Trinity Lake. And of course, we always had to go in and take a picture. You notice that I'm never the one that's sitting next to the edge. Joe is. He's the one that's always willing to go and take the ATVs where other people fear to tread. This is a majestic view of the Gemini Hills. This is basically where we found the water. So right out there is where we found the water. Navigating, it turns out that 3 heads are better than 1, but 1 GPS unit's better than 3 heads. Every time we tried to argue against whatever we were seeing with the GPS, we always lost. It was always correct. One of the things that Delmore taught me how to use was this Trimble GPS unit. Trying to write things on pieces of paper was not that easy. In fact, it was almost impossible. But by me going and having a programmable computer in that GPS device, I was able to record all the geological data that I wanted. Here we see setting up the geophysical equipment. Again, when we did this without the spacesuits, it was easy. With the spacesuits, it was more difficult. Here we are Stacy and I looking at a blanket of the meteorite pulverized rock, which I have a sample of it over there. Here again is another one of these hydrothermal pipes that you would not see from a from a satellite, but this is what we were picking up with the UAV, so taking a sample from it. There were never enough hands to carry everything. I hate to tell you what I'm looking for here. I'm looking for my rock hammer. I set it down somewhere. For using a stylus, kept losing these, so I had to go and put this to make it operate on the GPS. So we found ways of doing things. By the way, I did find my rock hammer. This was truly a Mars-like environment. When you were there, you were just awestruck by the area there. And we all, when we were on these EVAs, we all experienced the feelings of being on another planet. So this is what another thing that psychologically helped us with this particular mission. All right, our mission sadly ended on July the 27th. And just as we took the picture, here's our airplane coming in. So that was just sheer luck on that one. The female crew members left first with the 2 ATVs and empty barrels. Then the plane would come in again and take out all the heavy supplies, and then it's going to come in for us. Well, we were getting ready for the plane to come in. I said, my God, Joe, look what we see over there. It's fog coming in, and it's snow, and we got all our food supply and everything put up. We're going to be here for another week. And so we're sitting there, what are we going to do? And suddenly there comes the plane out of the clouds. And what we did is we quickly loaded everything. So you can see how we didn't really care how we got it in that plane. We wanted to get in that plane to get out of there, and we got out just as the snow hit. You can see that I'm very happy that we did that. Okay, then we returned to Resolute. I have to show you one picture here that I was really impressed with. This is what it looked like when we arrived on July the 1st, and when we come back, it's all going to be melted. And I saw an iceberg, a blue iceberg, and I was really impressed with that. So I wanted to share that with you, that we actually have blue ice. So this was an iceberg that was floating on July the 28th. For the first time in a month, we saw a sunset. And all of us on the plane, we were saying, you know, oh my God, look, there's a sunset. And everybody's looking at us, God, you weird people in here. But we were really thrilled by this. You know, we hadn't seen this for an entire month. Okay, then we went to the University of Maryland where the Mars Society was having their annual convention, and I gave a little brief review there. I might point out to you that my clothes were still in Resolute, and they would be in there for a week. So I got to wear the same clothes for quite a while. Okay, Zubin would present us the crew with a plaque. Says, your courage, skills, and perseverance have greatly assisted our goal of exploring and settling the red planet in our lifetime, the Mars Society. We basically auctioned off the Mars Society flag that flew over the HAB so that we could help finance future missions. We actually sold it for, it was over, I think, over $500 on that. Okay, and this is my final memento to an incredible adventure, and I want to thank you for letting me share this mission with you.